Imagine the universe as a vast ocean of elements. The most abundant, making up 75% of all elemental mass, is hydrogen. This simple element, represented by the symbol H and positioned proudly as the first on the periodic table, is more than just a number. It's the fundamental building block of the cosmos. Hydrogen's journey begins in the heart of stars, where it plays a starring role in stellar nucleosynthesis. This process involves hydrogen atoms fusing together under immense pressure and heat, releasing vast amounts of energy and forming heavier elements. It's this energy that lights up stars and ultimately, our skies. Beyond star formation, hydrogen's abundance and simplicity make it a key player in the structure of galaxies. It forms vast molecular clouds that can collapse under gravity to form new stars and planets, continuing the cosmic cycle of creation and transformation. So, why is this seemingly simple element so crucial? Let's dive into its atomic structure to find out. Hydrogen, with its lone proton and single electron, stands as the simplest of all elements. At the heart of hydrogen's atomic structure is a single proton forming its nucleus. This solitary proton is orbited by one electron, creating a beautifully simple atomic composition. This configuration is not just foundational to hydrogen itself, but forms the basis of understanding chemical properties across the entire periodic table. The atomic number of hydrogen is 1, which essentially counts the number of protons in an atom's nucleus. Since hydrogen has just one proton, it proudly holds the first position on the periodic table. This is more than just a numerical position. It symbolizes the starting point for the complex interplay of elements that make up our universe. Further delving into its structure, hydrogen's atomic mass also hovers around 1 atomic mass unit. This measurement gives us a comparative scale to weigh the mass of atoms, with hydrogen serving as a fundamental reference point. The atomic mass unit is defined such that 1/12 of the mass of a carbon-12 atom equals 1 atomic mass unit. Therefore, with its mass so close to this standard unit, hydrogen is not only the simplest, but also the lightest element known. This simplicity in structure translates to unique properties. For instance, at room temperature and standard pressure, hydrogen exists not as isolated atoms, but pairs up with another hydrogen atom to form hydrogen gas, represented as H2. This diatomic molecule is colorless, odorless, and highly flammable, playing a crucial role in both natural processes and human-made technologies. Hydrogen's electron configuration also invites a closer look. With 1 electron in the 1s orbital, hydrogen's electron shell is unique because it is the only element in the first period of the periodic table that does not need to share or transfer electrons to achieve stability. This electron arrangement makes hydrogen highly reactive and capable of forming bonds with a vast array of other elements. This minimalist design not only makes hydrogen the lightest element, but also one of the most intriguing in terms of its properties. At room temperature, hydrogen is not visible to the eye, yet it holds properties that are anything but ordinary. This simple element, consisting of just 1 proton and 1 electron, manifests as a colorless, odorless, and tasteless gas. Under normal conditions, hydrogen doesn't stand alone but pairs up, forming diatomic molecules known as H2. The sheer simplicity of hydrogen belies its intriguing characteristics, especially when we consider its boiling and melting points. Hydrogen has a boiling point of -423.17 degrees Fahrenheit and a melting point of -434.49 degrees Fahrenheit. These temperatures are so extreme that hydrogen is one of the few elements that can naturally exist in all 3 states of matter: gas, liquid, and solid, under varying atmospheric conditions. The transition of hydrogen between these states is not only a marvel of nature, but also a testament to its versatility. In its gaseous form, hydrogen is light and elusive, rising above other gases in the atmosphere. When cooled to its liquid state, it becomes a dense, energy-packed liquid used in various scientific and industrial applications. Even more fascinating is its solid state, where it adopts a crystalline structure, albeit under conditions of high pressure and extremely low temperatures. This ability to exist in 3 different states is not just a curious detail, but a crucial feature that enables hydrogen's widespread use in various technologies and energy systems. Its low boiling and melting points allow for easy transition from one state to another, making it an ideal candidate for applications that require high energy efficiency and clean combustion. Furthermore, hydrogen's reactivity is a significant asset. It readily forms compounds with most elements, notably oxygen, to create water, a reaction that is foundational to life on Earth and to hydrogen fuel cells, which hold promise for a sustainable energy future. With such extreme properties, it's no wonder hydrogen is highly reactive and forms compounds so readily. From the water we drink to the fuel in rockets, hydrogen's applications are vast and varied. As we delve into the myriad uses of this simple yet profound element, we'll uncover just how integral hydrogen is to our modern world, particularly in energy production, manufacturing, and beyond. Starting with energy production, hydrogen is a star player in the realm of fuel cells. These devices convert the chemical energy from hydrogen into electricity through a reaction with oxygen, with water being the only byproduct. This clean energy technology not only powers vehicles like cars and buses, but is also used in stationary power generation systems that provide electricity for buildings and remote locations. The allure of hydrogen fuel cells lies in their efficiency and their role in reducing harmful emissions. In the realm of chemical manufacturing, hydrogen's role cannot be overstated. It is crucial in the synthesis of ammonia, which is primarily used to produce fertilizers that support agriculture worldwide. Moreover, hydrogen is employed in the production of methanol, which serves as a building block in the production of various chemicals and fuels. These processes underscore hydrogen's critical role in sustaining and enhancing various industrial operations. Hydrogenation is another significant application. This process involves adding hydrogen to unsaturated fats and oils to convert them into saturated fats, which are more stable and have a longer shelf life. This is particularly important in the food industry, where hydrogenation helps in extending the usability of products. In the field of welding and metalworking, hydrogen is used as a shielding gas to prevent oxidation during welding. Its properties make it ideal for creating strong, clean welds. Additionally, in metallurgy, hydrogen serves as a reducing agent, a critical component in the purification and processing of metals. Rocket propulsion is yet another thrilling application of hydrogen. Due to its high energy content and clean combustion properties, hydrogen is used as a fuel in rocket engines, propelling spacecraft beyond the Earth's atmosphere. These uses demonstrate hydrogen's versatility and its potential to power not just industries, but also our future. A world fueled by hydrogen? This isn't just science fiction. Imagine a future where the skies are clearer and the air is fresher, all thanks to the most abundant element in the universe, hydrogen. This scenario is grounded in the concept of the hydrogen economy, a transformative approach that envisions hydrogen as a cornerstone of energy systems worldwide. The hydrogen economy proposes using hydrogen as a versatile, clean energy carrier. Unlike fossil fuels, when hydrogen is used in fuel cells, it reacts with oxygen to produce electricity, heat, and water, with water being the only emission. This stark contrast to the carbon emissions from traditional energy sources offers a breath of fresh air, quite literally, in our fight against air pollution and climate change. Moreover, hydrogen's prowess doesn't end with clean emissions. It also plays a crucial role in reducing our reliance on fossil fuels. Currently, the transportation sector, which heavily depends on oil, is one of the largest contributors to global carbon emissions. Hydrogen fuel cells could revolutionize this sector. Cars, buses, and even larger vehicles like trucks and trains can be powered by hydrogen, potentially transforming how we think about transport and its environmental impact. The journey towards a hydrogen-powered future is fueled by continuous advancements in technology. Researchers and engineers are making significant strides in improving the efficiency of hydrogen production, storage, and distribution. Methods such as electrolysis, where electricity splits water into hydrogen and oxygen, are becoming more efficient and increasingly powered by renewable sources like solar and wind energy. Additionally, Advancements in hydrogen storage, such as solid-state hydrogen storage materials, are making it safer and more feasible to store and transport hydrogen, paving the way for its widespread use across various sectors, including industry and residential energy. As we continue to innovate, the dream of a hydrogen-fueled future becomes ever more attainable. Today, we've explored the universe's simplest yet most abundant element, hydrogen. Starting from its position as the first element on the periodic table, hydrogen's journey is fascinating due to its simplicity and versatility. Comprising a lone proton and an electron, it's not only the lightest element, but also one of the most reactive forming compounds, ranging from water to complex hydrides. At room temperature, hydrogen presents as a colorless, odorless gas, but its low boiling and melting points allow it to exist in all three states of matter. Industrially, hydrogen's role is expansive, vital in energy production through fuel cells, manufacturing chemicals like ammonia and methanol, and even in metalworking and rocket propulsion. Looking ahead, the vision of a hydrogen economy offers a promising horizon. This concept envisions hydrogen as a cornerstone of sustainable energy, potentially revolutionizing how we power our industries, vehicles, and cities. As we stand on the brink of energy revolution, hydrogen isn't just a part of the universe, it's a beacon for our sustainable future.